So now we have some evidence in front of us. Let's draw some conclusions, shall we? We've already been banging on about how there's this domain and range swap, right? Where you had, I mean, this is a bit boring, isn't it? Domain and range are both all real values, right? So domain and range for the original are all real. I should write that. Domain x is all real values, range y is all real values, okay? So since it's everywhere, the inverse has the same domain and range. Whoops. Okay. What happens over here? Well, you've already been given this restriction, right? So that's a domain restriction here, which becomes a range restriction. What is the range of the original function? The range of the original function. Range is up, down, isn't it? Okay, and this is my original. So it's greater than or equal to -1. It does include the boundary, doesn't it? Okay, so range here, y is greater than or equal to -1, which of course corresponds to the domain of your inverse, right? The domain here is x is greater than or equal to -1, -1, which of course makes sense when you look at the square root function. So far, so good. Okay. One last time, let's have a look at this guy. The original domain here, x is greater than or equal to -1. So let's have a look here. Actually, is it equal to? Did they exclude the boundary? They did exclude the boundary. Of course they exclude it because there's an asymptote, right? So we ought to exclude it on the range of our inverse. Y is greater than -1. Okay? And the range and the domain, conversely, not that interesting here because again, they go everywhere. Okay? So here's my first geometric property that I want to know. Geometric properties that I'm after. Okay? Domain and range swapped. It sounds simple, doesn't it? Okay, but it's easy to miss. It's very confusing sometimes. You get confused between domain of this, domain of that, and so on. Okay. Now the other thing which I wanted to show you, which you can do very well, but I cannot do so much because my whiteboard is stuck to the wall. So I have drawn a new one. Okay, is that you can see there's a pattern here, isn't there? Visually, you can see what's going on. Okay. These shapes, when you compare function and inverse function, function and inverse function, function and inverse function, okay? How would you articulate, express, what's the visual relationship between these? It might be a little easier if you turn your head. It's a reflection, isn't it? What kind of reflection is it? Because as you know, we can reflect in lots of different ways. It's a reflection across a particular line, right? Namely, y equals x. This is why I looked at this coordinate here. I asked you to work out what this coordinate was. You're going to find it's the x and the y coordinate are the same. And of course you can see here, well, it's the origin, so that's a bit boring, okay? But if you draw in y equals x, which you should, do it now, you're going to get this kind of line. So if you twist your head at 45 degrees, because that's the angle that y equals x forms, right? You're always going to get this symmetry. Okay, and by the way, this is how I knew that I was only going to get one intercept over here, right? Okay, now what I actually suggest you do, you don't have to turn your head, look at this thing. You can literally take your page and turn it, okay? So now when you have it like this, do you guys know how do you make a reflection? When you've got a shape, think back to when did you do transformations? Translation and reflection and rotation, okay? You would get a ruler out, right? And you'd say, look, this is the line that I'm reflecting across, okay? So you take a point like this one, okay? And you get your ruler, and you say, okay, I'm going to go toward the line of reflection, and I'm going to form a perpendicular line, okay? So let me see if I can do this, okay? All right, so you form a line like that, okay? And you say, all right, how far is this point that I'm reflecting? How far is it from the line that I'm reflecting across? And it might be something like 3 centimeters, right? So you go 3 centimeters this way, you go 3 centimeters the other way, and you draw a point in. And eventually, this is, let's see, I better put a clipboard up. I don't want to put a permanent marker on the whiteboard by accident. You will do something like this. Let's try it, shall we? And you should give it a go as well. There you go. I've turned it at 45 degrees. Okay. So this comes across here this distance. So there's my reflected point, right? This comes across here. There's my reflected point. There's going to be a reflected point up there, right? I could find another reflected point over here, which would be that distance. Okay, and then you connect the dots. You get this guy, which sort of matches what you got there. You get the idea. You can actually see. Wait, that way. Sorry. You can see the reflection because of the distances, right? And you should do that in here just so you can make it obvious to yourself what's going on. Okay.